Hi, today we're going to talk about section 6.2, which is representations of functions. It's also in your book on page 250. The first thing that we're going to do today is define what a function rule is. And a function rule is just an equation that describes the relationship between the inputs, and remember that's an independent variable, and the outputs, which is your dependent variable. Okay, so that is what function rule is, an equation that describes the relationships between the inputs and the outputs. So if we go ahead and look at the key idea here, it's kind of like you throw something in to like this machine and it does something to it, and then you get your output. And when it's in the machine, it's telling it what to do, and that's your equation. Okay, so I think this is a pretty good visual. You put your input in, this box does does something to it, and then it comes out. And what it does to it is your function rule. So let's look at example 1, writing function rules. You're gonna see that a lot of the things in the beginning of this chapter are very similar to when we did our equations unit. So don't overthink it too much. They're almost exactly the same. So this part should be kind of a review. So it says write a function rule for the output is 5 less than the input. Okay, so the output, remember, is your y, is 5 less than the input. So that means whatever the input is, you have to take 5 away from that. It's 5 less than that. So your input is x and you minus 5. So the function rule would be y equals x minus 5. B, write a function rule for the output is the square of the input. So the output is y, the square of the input would be x squared. So y equals x squared. Example 2 is just evaluating a function. And again, it's the same thing as if you evaluate an equation. They're going to give you what your input is, and you have to tell us what the output is. So if you have your function rule of y equals 2x plus 5, your input is 3, plug 3 in for x, and you get 2 times 3 is 6, 6 plus 5 is 11. So when x equals 3, y equals 11. All right, let's try a couple on our own here. Number 1 says, write a function rule for the output is 1/4 of the input. Okay, so well, I'm just gonna put number 1 up here actually. So the output, y equals 1/4 of the input. So 1/4 times x, which I can write 1/4 x. So it should be y equals 1/4 x. Number 2, 3, and 4 says find the value of y when x equals 5. So I'm just plugging 5 in for x. So on number 2, I have y equals 4 times 5 minus 1. Well, 4 times 5 is 20. 20 minus 1 would be 19. Number 3, y equals 10 times 5. Well, 10 times 5 is 50, so y equals 50. And then number 4, y equals 7 minus 3 times 5. So y equals 7 minus 15. So y equals -8. Okay, so again, very similar to when we did equations. Next key idea, functions as tables and graphs. A function can be represented by an input-output table and by a graph. The table and graph below represent the function y equals x plus 2. So again, same kind of thing. By drawing a line through the points, you graph all the solutions of the function. Remember, really this line here is just really an infinite number of dots together that are solutions for this function. Okay, so there's a dot here, here, all the way up. This line isn't, it's a line, but it's really just a series of dots, an infinite number of dots that are solutions to this function. And your input, remember, is x, your output is y. Plug your input into your function rule, get your y, and then you have your coordinate pair, or your ordered pair. Example 3, graph the function y equals negative 2x plus 1 using inputs of negative 1, 0, 1, and 2. Make an input-output table. There we go. So they have the input, negative 1. They plug it into the function rule, and they get their output. So negative 1, 3, 0, 1, 1, negative 1, 2, negative 3. They plot those on their graph and draw a line through the points, and they get their graph. All right, number 5. Sorry about that. Number 5, it says graph y equals x plus 1. Okay, so we're going to make our input-output table. I'm not going to do it as large as they did it. So I'm just going to go over here, and we'll just do x and y. And let's just use the numbers that they use. They use negative 1, 0, 1, and 2. And we'll just do that. If on the assignment today, if it asks you to graph, just use these 4 numbers, and that way we're all the same. And so just plug your x in. So negative 1, plug it in for x. Negative 1 plus 1 would be 0. So my output is 0. Plug 0 in. 0 plus 1 is 1. Plug your 1 in. 1 plus 1 is 2. And then 2 plus 1 is 3. And then I'm going to go ahead and plot these points. So negative 1, 0. I'm going to use my my mouse on that. So there you go. And then we have 0, 1. And then we have 1, 2. And then we have 2, 3. And then go ahead and use a straight edge. Some of us last time were not using a straight edge when we were connecting our points. Please use a straight edge. Oh. Now on here I have kind of a tool that lets me do that. So, and then put your arrows on the end to show that it keeps going on forever. It doesn't stop. And that would be your graph. All right. If you want to stop the video and try 6 and 7 on your own, and then we can check it, that would be fine. If you'd rather do it together, that's fine as well. All right, number 6, let's make our table. So I have x, y, and again, I'm going to do negative 1, 0, 1, and 2. So plug in negative 1. So that would be negative 1 times negative 3 would be positive 3. Plug in 0 would be 0. Plug in 1, it would be negative 3. And plug in 2, it would be negative 6. So I'm going to go negative 1, 3. 1, 2, 3. Put a dot. 0, 0. 1, negative 3. Ooh, that circle kind of got away on me. And 2, -6. And then go ahead and get your straight edge and connect those points and put your arrow. All right, last one, number 7. Get our table. Again, if you'd rather do it on your own and check it, you can stop the video here and check it when you get done. Turn it back on, or we could do it together. All right, so I'm going to plug in -1. So 3 times -1 is -3. -3 plus 2 is -1. Right? -1. Yes. Okay, so then 0. 3 times 0 is 0. 0 plus 2 is 2. 1 times 3 is 3. 3 plus 2 is 5. 2 times 3 is 6. 6 plus 2 is 8. Okay, let's go ahead and plot those. So -1, -1 is right there. Oh yeah, 0, 2 is right here. 1, 5. And 2, 8. And then I'm going to connect those with the straight edge. And again, I'm not asking you to be perfect on your lines. Just make sure that you're using a straight edge. All right, and that is 6.2.